Hey, you talked a little bit about volumes there, data volumes. We're in the O'Hare flight path here, if you didn't know. So you talked about data volumes, 15, 20 million, but that's going to be within a single instance, and that's
Correct.
going to be like input transactions. But when you go through an accounting rules engine, you end up exploding
1:6,
those.
yeah.
Yeah, so tell us about kind of how the volume grows through the platform.
Yeah, so think of it in three stages. You go from the raw transactions coming out of the accounting rules. There's about, between the raw transactions and source systems, there's about a 1:6 explosion on an average. Then you go from the ARE, which is the credit and debits, over to the arrangement ledger. There's about a 1:4 that happens out there. And then by the time you get to the extracts, there's about sometimes a 1:10 to 1:20 that could happen there. So very quickly, this thing will multiply, say 6 times 4 is 24 times 20. You could be talking about, for each transaction, about 200 to 240 multiple that grows in terms of transactions on a daily basis. Although when you store it, and then storing of it is I think a vlog of its own.
Okay.
What is the optimal way to store it? By the way, we still store it the way,
Yeah.
I think I still remember the chart of the volume
Yeah.
and
No, and I'll show that.
yeah.
Actually, if you're interested, go
Yeah.
ahead, talk about that. For
Yeah,
me.
so I think it's a very interesting chart because there was a big debate on when you had this much. We just talked about the explosion. You got about, one transaction exploding 200 times before it gets posted.
And then you've got to talk about the balances are a separate volume of themselves because they carry
Exactly.
all the history,
Yep.
right? So you've got all the transactions that are a day's worth of transactions. Then you've got all that at the detail level. Then you've got all that history at the detail level for customers.
Absolutely.
So the volumes are very large. Okay, go ahead.
Very large. So you got to give this a lot of thought because when you approach these things simplistically, as a lot of systems do, that they think the easiest thing. In fact, functional folks and people in the business just always think in terms of balances. That's what
Yeah.
makes most sense to them, and that's the most useful
Positions.
metric.
Every
That's all.
analysis begins with a position,
with
a
the
balance.
balance. So what they would love to see, that normally just translates into, take all these movements and then just create a balance for me for today, and I'm a happy camper. So, and actually that starts making sense, saying, okay, we get 200 million transactions, what am I going to do? But actually, when you collapse it and store it, you're just storing it maybe 1 million balances, and you feel really good about that. But then the issue is the history. As it starts building up, what you also find out is, on certain days, you may have no movement that occurs, but you still have to calculate the entire balance all over again, pretty much in order to give a sense of what the positions is on that day, which is quite redundant. And what we found is that the balances, if you kept storing balances as the way that you thought of your unit of work, it created a massive terabyte. At that time, terabyte was a big
Yes.
deal. It wasn't
Yeah.
in the petabyte
Yeah.
range
No,
yet.
no, but
We're still in the terabyte range. Terabyte was and is kind of still a number that we worry about.
But this is effectively a general ledger system. You're
Yeah.
talking about terabytes in a general ledger system,
Yeah,
right? Yeah,
exactly.
So
So,
this is a very large number for this kind of system.
and for very traditional, and we're talking 10 years back when we started, we're talking traditional RDBMS, DB2. I mean, we're not talking still in the Hadoop arena or whatever. So, and when we saw that, compared to when we looked at the other extreme, right? So there's one philosophy that says store balances. There's another philosophy that says it's event driven, and I'm sure Kip has provided a lot of insights into event driven architectures, which basically have the philosophy: store the events at the most granular detail, and that's the source of truth. And whatever summaries that you need, do that at the time that you need the summaries, which means a very high level of compute fundamentally. So,
Yep.
so both of them in the extreme spectrums are either a compute problem or a storage problem. So finding that sweet spot in the middle of it was extremely key, and I think we found it as part of building the system. And that's what, there is this parabola
Yep.
shape that comes in, where on the x-axis you're talking about amount of aggregation that's going on, and on the y-axis you can think about the amount of storage that's going on. So when it's very little aggregation, which means it's a transaction, it's just your events being stored, think of that's a pretty high level, because think of 200 million transactions a day are getting stored. So that's a pretty high amount of storage. On the other side of the x-axis, when you're talking about aggregation, balances are being stored. That too is a very high level, that you're storing a million a day or 2 million a day. So the sweet spot is not to store the events, not to store the balances, but storing something in between, and we call that a summary of movements, which was, it's used in other systems as well, but I think we were quite um, innovative to use it, and basically the way to think about it is we call it a journal summary movement file, where you have basically one row encapsulating 13 buckets, one for each month, and you have 13 such rows that are there for every month, and that gives you a year. And then you have a row for every dailies that they're called, so 30 buckets in that. With that structure, what could have been stored, or what was being stored in 4 terabytes got stored probably in about 25 to 30 gigs. So that was the level of compression. But still, what it meant is we kept it in a smart way. There was still some compute that needed to be done. Obviously, you're in that sweet spot, so you still have to do some compute. But that compute, using some of the in-memory techniques, was much more efficient for us than actually storing the event data or that. So anyway, that was a interesting problem that left a hallmark, and so that stuff, some of the stuff you don't forget.
No. You described that very well. So.